All right, Algebra 1, lesson 1.7. So today we're going to get into multiplying polynomials. We just finished adding and subtracting polynomials. So today we just take it to the very next step of multiplying polynomials. So in order to multiply polynomials, we have to remember our power rules. And so what that means, well, our rules of exponents, our exponent rules. And so I have a chart up here that has I think all of them on it, but the one we're going to look at is the product rule. It says to multiply when two bases are the same, write the base and add the exponents. Now the base is the number that is being raised to the power of the exponent. So this is a to the power of n times a to the power of m. So you write the base, a, and then the exponent is both the exponents added together, n plus m, okay? So let's go ahead and look at some examples here. X to the fourth times x squared is going to be, we write the base, we have the same base. So we're going to write x. 4 plus 2 is 6. And it's that simple when you're multiplying a same base with an exponent, okay? Now this one's a little bit trickier because you see it's got some y's and some x's and all kinds of things in here. But if you notice, there's absolutely no addition and no subtraction. And that's key because the addition and subtraction, remember, is like a brick wall. It divides the terms. You can't combine stuff unless it matches exactly between addition and subtraction. But when it comes to multiplication, we have to remember that order doesn't matter. 2 times 3 times 7 times 10 is the same thing as 10 times 3 times 2 times 7. Matter of fact, that's the same thing as 2 times 5 times 3 times 2 times 7. See, the 2 and the 5, guess what they make? 10. So subtraction is definitely different than addition. I'm sorry, multiplication is definitely different than addition and subtraction. So the easiest way to look at this is to add together all the exponents of y and all the exponents of x because, and only because, everything is being multiplied, okay? Since there's no addition or subtraction here. So we're always going to start with the x's first because x comes before y in the alphabet. So this is x to the power of 1 and x to the power of 1. So it's x squared. And then we're going to, remember, we're multiplying, so we can just write it right next to it. That indicates multiplication between when you have two letters touching or a letter and a number touching. Okay, so I've done the x and I've done the x. I've only got some y's left. I've got a y to the power of 3, y to the power of 1, 3 plus 1 is 4, and a y to the power of 2. Add 2 more, and I'm going to get y to the power of 6. So this is our final answer. And just to show you why that works, we've y to the power of 3 is y times y times y times x times y squared. There's 2 more y's times x. So if you notice, this was the first one right here. I don't want to call it a term because terms are separated by what? By addition and subtraction. Y to the third. There it is. Then I've got xy, there it is. Then I've got y squared, there it is. And then I've got just an x by itself. And when you're multiplying, remember, we've got 1, 2, 3, 4, 5, 6 y's times themselves because we can put these in multiplication, we can put them in any order we want. So that's y to the 6th. Then we have 2 x's times x times x. We just wrote these x's first and the y second. But that's why this works, because there's no addition and it's all multiplication. All right, so what does that have to do with polynomials? Well, let's look at this. Sometimes there's different ways to multiply polynomials, okay? You're going to have a monomial, remember that's one term, times monomial, which is a singular term as well. One term times one term. Then you have a monomial times a binomial, which is one term times 2 terms. Remember, when they're touching, that means they're multiplying. A binomial times a binomial. Now we should recognize this as FOIL. and then also a binomial times a trinomial. The rules remain the same no matter which kind you use. You want to make sure that you're multiplying each term in the first polynomial by each term in the second polynomial, okay? And then you put all those answers together and simplify if needed. Now, if after we go through this video, you're still wanting some more practice, you can come back and press pause, figure these out on your own, because there's the answers for you to check them against. All right, monomial times a monomial. Let me move this so you can see. I've got one term right here, 2xy times 5xy. It's done just like if you were going to multiply these two terms together. We have 2 times x times y times 5 times x. And remember, order doesn't matter with multiplication, so it could be 2 times 5 times x times y. So 2 times 5 is 10. X times x is x squared, and then we've got a y right there. So our answer is 10 x squared y. And that's our final answer. Monomial times a monomial yields another monomial. Make sure you write your examples in your notes. All right, so I've got some monomial practice for you because that was simple enough. Multiply the numbers, multiply the variables, write your answers down. Pretty easy to do. You got this. Press pause, get her done, and come back. 3x squared times 4x to the fourth. 3 times 4 is 12. And then we've got our variable of x. I'm just going to write it down so I don't get confused. And remember, I'm going to add my exponents. 4 plus 2 is 6. 12x to the 6. Multiply 4 times 5, we get 20. I'm going to write my variable, the same base down, add my exponents. 4 plus 5 is 9. 20x to the power of 9. Oh, there's no numbers here. What do I do? Okay, well, we just skip that step. I'm going to start with writing down my x's. Okay, so x is to the power of 2 and x is to the power of 3. 2 plus 3 is 5. Okay, I'm done with those. Now I'm going to do my y's. Y, this is the power of 2, and this is the power of 1, so that's 3. Okay, I'm done with it. X to the power of 5 times y to the power of 3 is my answer. Okay, so back to the numbers again. First, I'm going to start by adding my coefficients. -2 times a +3. If you have an odd number of negatives when you're multiplying, your answer is negative. So a negative times a positive, there's only one negative. So our answer is negative. 2 times 3 is 6. Okay, cross those out. We're done with the numbers. Now I want to look at my x's. I've got to write my base. I'm going to add my exponents. 8 plus 2 is 10. Okay, now I've got to look at my y's, write my base. 4 plus, what's here? It's a 1. It is 5. And so -6x to the 10th, y to the 5th is my final answer. Now, what about a monomial times a binomial? This gets into our distribution again. Remember, we saw that when we were subtracting polynomials, we had to distribute the negative sign to the polynomial that was being multiplied. But here, what we're going to distribute is our monomial into the binomial. Okay, so we're going to start with 3a times 2a. So I'm going to multiply 3 times 2. Let me go ahead. I'm just looking at this one right now. 3 times 2 is 6, and then a times a is a squared, okay? So I did like a monomial times a monomial, and I got a monomial. Now to get my second term, I have to use that same monomial at the beginning and multiply it by a -4. You can't forget this negative sign in the front, okay? A lot of times I see students forgetting that and just doing it times a +4, and they just kind of dropped that. They just kind of forgot about it. It just disappeared. But this is not something that's able to disappear in math. It's very important to always pay attention to negatives. It's one of the easiest simple mistakes that happen that get people tripped up. So you got to pay attention to those. All right, so 3a times -4. Well, this is a positive, this is a negative. That's an odd numbered amount of negatives, so our answer is negative. 3 times 4 is 12. So our answer is 6a squared minus 12. And I have it written out here for you. 3a times 2a is 6a squared. 3a times -4 is -12a. So our answer is 6a squared minus 12. Make sure you're writing your examples in the notes. You can always go back and pause, rewind. Now, binomial times a binomial. I'm going to show you two different ways to do this. The way that most people are familiar with is what's called FOIL. And that's the way we're going to go over first. It utilizes a mnemonic called first, inside, outside, last, which helps us to be able to make sure we've multiplied all of the things inside of our terms. So we're going to start with that. So FOIL for first, we're going to multiply the first term in each binomial. This is a binomial and this is a binomial. So the first term in each binomial. So 2x times x is going to be our first. And so that equals 2 times 1 is 2, x times x is x squared. See, I kept the base and added the exponents. Same base, 1 plus 1 is 2. You didn't know you were doing that already, did you? All right, so FOIL. Oh, oops, let's go back. Let's change that to yellow. Oh, outside. That means the ones on the outer edges. So this one and this one, I highlighted it in yellow for us. 2x times -3. You have to get that negative in there. So let's do the coefficients and the constants, the numbers first. 2 times -3. There's only one negative, so our answer is negative. 2 times 3 is 6. Only one variable, so I'm just going to write that down. Okay, now let's look at the I inside. That means these two terms that are right here on the inside, a +5 and an x. So +5 times x is 5x. All right, and L. Makes sense that the last one is last. That means the last term in each binomial. So this is the last term in the first binomial. And this is the last term in the second binomial. So we've got a +5 times a -3 is a -15. Well, Miss Andrea, what do we do next? Okay, well, I've got two terms right here in the middle that are exactly the same, a -6 and a +5. So I'm actually going to go ahead and combine them right here. A -6 and a +5 make a -1x. I can write that as simply -x. I no longer need these because I've combined them down to 1. Okay, so I'm left with 2x squared minus x minus 15. And that's my final answer for multiplying this binomial times a binomial. So that is way number 1. And like I said, it's FOIL, so many people are already familiar with it. So if you want to skip way number 2, you're welcome to, but I am going to go over it. I prefer way number 2 because when you get into multiplying binomials times trinomials, or even trinomials times a quadrinomial, you will have the understanding of how to do those. This works no matter how many polynomials, what level of polynomial you're multiplying together. Okay, so you break up your first polynomial into each of the terms, and you're going to write it vertically down like this: 2x, and then this is a +5. So you write each term down in a row. Okay, and then you're going to take the second binomial and multiply it out times each of those terms. Okay, so I've got 2x times x minus 3, and I've got 5 times x minus 3. Okay, and so when you do that, you're multiplying each term by each term. You see how everything is getting its own turn? So 2x times x is going to be 2x squared. 2x times -3 is -6x. Oops, let's switch over here to blue. 5 times x is 5x. I like to line these up. It's going to make my life easier later. And 5 times -3 is -15. Now we can just combine the like terms. I see there's no like terms with this one, so I can just bring it down. 2x squared, -6x, and +5x become a -x. And then I only have the one constant, -15. So for me, I prefer this way. This is more traditional math. This helps you understand what you're doing and why you do it, and it helps you in the future. And we got the same number as answer as we did when we used the FOIL method. All right, so a common mistake with binomials is when you see something such as x plus 3 squared, most people want to try to distribute this, but that's not right. Have you ever seen distribution coming from behind the parentheses? No, if it is, it's not written correctly. Exponents don't get distributed to what's inside it. Exponents tell us that it's that thing being multiplied by itself. So if we have x plus 3 squared, that really is x plus 3 times x plus 3. Then you have to do one of the two multiplication methods that we just went over to get your final answer. If you tried to do x squared plus 9, you'd be wrong. And I don't want you to see I don't want to see you get an answer wrong on your quiz or your test. Make sure you're practicing these correctly. It's x plus 3 times x plus 3. I know y'all understand that, right? Now, binomial times binomial practice. Go ahead and pause the video and work these out on your own. Come back to me. All right, so I've got two binomials here. I'm going to do one each way. So I'm going to start with FOIL, F-O-I-L. Actually, let's do it in different colors. F is going to be our first, 4x times 2x. 4x times 2x is 8x squared. All right, outside, 4 and -9. 4x times -9 is -36x. Inside, -7 and 2x. -7 times 2x is -14x. And the last, -7 times -9 is, we have two negatives here. So it's an even number. So our answer is going to be positive. So 9 times 7 is 63. I'm going to go ahead and combine these. -36 and -14 is a -6, 7, 8, 9, 10, 4, 5, 50x. And so I got the answer 8x squared. Okay, done with that. Minus 50x. Done with that, plus 63, done with that. Let's see if I got that correct. Oh, look, I did, yay. Clear these drawings so we can move on to the next one. All right, so this one I'm gonna do the second method, which is the way I prefer. So I'm gonna do 4x, wrote the first term right there, and my second term is a +3, and then I'm going to multiply each of them by this whole binomial here, times 7x minus 5, 7x minus 5, okay? So 4x times 7x, 4 times 7 is 28x squared, 4x times -5 is -20x. 3 times 7x, 3 times 7 is 21 with an x. Oops, I want to put that right here. Let me go ahead and erase that. It just makes it easier for me. You can write it there, but I like to line up my like terms. 3 times -5 is -15. And so I've got 28x squared. A -20 and a +21 make a +1. Oh, I don't need to write 1, do I? A +x minus 15. Let's see if we got the correct answer. 28x squared plus x minus 15. Way to go, everyone. Great job. All right, so now we've got here a squared, and I know y'all got this right because we just talked about it, right? So this is really 3x minus 5 times 3x minus 5, remember? So let's go ahead and let's FOIL the first one. And I'll start with first. 3x times 3x is going to be 9x squared. Okay, then let's go to outside. 3x times negative 5 is negative 15x. And then inside, negative 5, positive 3x is negative 15x. And then last, negative 5 and negative 5 is going to be a positive 25. Combine these, negative 15x is negative 30x, so we no longer need those. And our answer is 9x squared minus 30x plus 25. And let's see, looks like we got it correct. All right, moving on here, we've got again with the squareds, we've got 2x squared minus 5x times 2x squared minus 5x. You do not have to write it that way if you're going to use the second method. You can just go ahead and write 2x squared minus 5x, and then the second one, 2x squared minus 5x, 2x squared minus 5x. Let's distribute. 2 times 2 is 4. X squared times x squared is going to be x to the 4th. 2x squared minus 5x. 2 times negative 5 is negative 10x cubed. 5x times 2x squared, negative 5x, excuse me, is going to be negative 10x cubed. And negative 5x times negative 5x is a positive 25x squared. Oh my gracious, I'm so not fitting that in very well. Let's see, 4x to the 4th minus 20x cubed plus 25x squared. Oh, barely fit. And our answers match. We got it correct. Now, I want you to make sure you've taken good notes. If this is your first time watching it, you didn't take notes, go back, watch the video again, take good notes. It'll help you with your quizzes, it'll help you with your homework, and ultimately it helps you with your tests. When you activate multiple types of learning, you're hearing, you're seeing, and you're writing all at the same time, you're going to have a better job of remembering and recalling things later on. So that's it for this lesson. We'll see you back for the next lesson.